Okay, let's look at this one then. 1 mark, state the principle of conservation of energy. You can see what I've written there. Energy cannot be created or destroyed. This is the mark scheme. Look, it is quite clear that this needs, the underlining in a mark scheme means all those words are vital. And it says do not accept that energy has to be, or energy can only be conserved. So it's just one of those physics facts you'll learn enough by heart. Okay. Explain how this principle applies to an object falling from rest through the air. And that, look, that is in bold. All right, so it's an object falling, right? If an object is falling, an object falling from height, an object at height has gravitational potential energy, and you need to write this in full, okay? As it falls, its height reduces, which means, that's a therefore, its GPE decreases. Now the GPE doesn't disappear, that GPE is converted into kinetic energy, yeah, as its speed increases. So what I've done there actually is I've linked GPE to height, and I have linked KE to speed. All right, now that is probably only going to give you the first mark here. 3 marks altogether. Obviously GPE is turning into kinetic energy, but the fact that it's moving through the air means that that is not 100% efficient. Some energy is going to be dissipated because of air resistance, because of friction with the air. All right, so for your second mark, some energy is transferred to the air due to, you could say, friction or air resistance. But the third mark is looking for this little bit to explain where that actually goes. Yes, it's transferred to the air, but what type does it become? Right? This becomes kinetic energy or internal energy of the air particles. Okay, so you might think that you've got all of this and actually only got 1 out of 3. Next bit. A child of mass 16 kilograms starts from rest at the top of a slide and reaches the bottom with a speed of 6. The slide is 4 meters long and there is a difference in height of 2 meters between the top and the bottom. Okay, so the child is going from the top to the bottom. There is GPE transferred to KE, but there is also some work done. All right, so calculate the work done against friction. We need to work out the GPE at the top and the KE at the bottom, don't we? So GPE at the top is mgh, so that is our 16 times 9.81. How tall is this? Which one of these distances am I using for GPE? Vertical height. Okay, so the GPE at the top, I think that comes to 376.7 joules. And the KE at the bottom is half mv squared. So it's half times 16 times, where's the speed at the bottom? 6 squared. And that comes out at 288. Just remember it's only the V that is squared, right? So that's our GPE at the top, That's a K at the bottom. The difference is the work done. Okay, work done is 376.7 minus 208 equals 88.7 joules. All right. And then finally, use your answer. So use this to calculate the mean frictional force acting on the child. So here's where friction is acting. All along that slide, right? This is our work done formula. So work done is the force times the distance. That's the frictional force times the distance that the distance touching the slide. So what do we need? We need F equals W over X. So that is 88.7 over, and now we use the distance that the friction force is in contact, and that is the 4 meters long. Okay, there you go.